Okay, so be careful. We talked about areas of rectangles, parallelograms, and squares. If you don't know your formulas, you're not going to be able to do those types of problems. So you got to keep those formulas straight. Now we're going to move into some more formulas because we're going to deal with different shapes. So first off, we're going to deal with the area of a triangle. Does anybody know from previous knowledge the formula for area of a triangle? Area of a triangle. Okay, and there's half of a hand up and that's it. So you've learned this before, but you don't remember it. Well, that's an issue in math. Things that you learn, you've got to figure out a way to remember. Usually that's by studying and reviewing. So be careful here. Remember what I do to help you remember. Every time I see a problem involving area of a triangle, I want you to start the problem doing what? Showing the formula, writing the formula. Because every time you write the formula, it's going to help you to remember it. Now, look, this chapter, we already have done area of a rectangle, area of a square, area of a parallelogram. We're going to do area of a triangle. We're going to do area of a trapezoid. We're going to do area of a rhombus. We're going to do area of a circle. We're going to do lots of areas. Your brain has to keep all those straight. To help in keeping them straight, I like to use a subscript. So in this, I use the subscript of the triangle. You could also do the word TRI or triangle if you want. Area of what? Of a triangle. Look, you need to make that reference in your brain. And so the first time you write a formula, I expect to see that symbol there. Because your brain has to keep track of area of a triangle versus area of a parallelogram. Area of a triangle versus area of a trapezoid. They're all different formulas. How does your brain trigger which one to give you? Well, again, by that subscript, it's going to help your brain out. So that's a little thing, but it's important. All right, so take your blue. Formula for area of a triangle is pretty similar to area of a parallelogram. It is 1/2 base, and then I'll finish off in green, times height. 1/2 base times height. So take your red. Let's assume that the base is this bottom side. I'll put a red D there. Then the height isn't shown. We're going to have to show it. Take your green, start at the vertex, come down to that side with a perpendicular line, and then put the H there. So to find the area of that triangle, we would do 1/2 the value of the base and then multiply it times the height. Well, like parallelograms and rectangles and such, the height is the key. How do you know the height? The height is the perpendicular distance between the base and the opposite vertex. The vertex is the point. Did we not go from the opposite vertex and perpendicular to the base? We did. And that's how you can recognize the height. It's always going to be perpendicular to your base and it's going to go to the opposite vertex. Now, in reality, any triangle can have 3 different heights. Because how many sides does a triangle have? 3. You know what? Any of the 3 sides can be the base. We always want to think of the triangle as sitting on the base. Well, not necessarily so. Now, the first example, we put the base on the bottom. But does the base have to be on the bottom? The answer is no. What you have to recognize as a student is, I got to make sure that I use the correct side of the triangle as the base that corresponds to the height I'm given. So if you look at the first triangle here, you have 3 sides. Which side would be the base according to the height that's given? So take your red and just mark a little B on the side you think is the base. It's either going to be down here or here or here. One of those is correct. Only mark one of them. Which side is the base? Basically, I have bottom, left, or right. Those are the 3 choices, bottom, left, or right. You got to pick which one is the base. So on 3, I want you to tell me bottom, left, or right. Here we go. 1, 2, 3. Left, and that is correct. That's got to be the base if that's the height. Now, this is the exact same triangle in the middle, but I'm showing you a different possibility for the height. So where would the base be on that one? Go ahead and write it down. Where would your base be? Bottom left or right? Class, which way? Right. That one, it's right, and the third one is the classic way with it on the bottom. They're all the same triangle. And look, the only thing that makes these hard is, look, one, remember the formula. What do students forget when doing the area of a triangle? They forget the half. Can I show you something real quick? Don't write this in your notes for time's sake. Usually I take paper and I cut it up and stuff. But I'm going to take a rectangle, right? And do you agree that this is the base? Do you agree that that is the height? Yes? Okay. If I were to take a pair of scissors and I were to slice this rectangle in half, those triangles would be exactly the same size. Exactly. Which means their area would be the same. So if I figured out the area of the rectangle, I would take this base and multiply it times this height. For example, let's suppose the base was 10 and the height was, I don't know, it looks like 6. What's the area of the rectangle? 60 units squared, yes? Base times height. What's the area of one of the triangles? Half of that, right? Because you get 2 triangles per every rectangle, and they're exactly the same size. So what would one of the triangles be? 30 units squared, 1/2 the base times the height. So why the half? Because you get 2 per every parallelogram, doesn't matter, rectangle, you get 2, and so the area of one of them is half of that. But you can't forget the half, don't forget the half, don't forget the half, don't forget the half, don't forget the half. All right, so here again, base went in here if you didn't figure that out. We're going to choose the base according to whichever side the height is perpendicular to, right? And that's what we just did. So that's a key thing. You got to know which side is the base to go with the corresponding height. Now, sometimes the book will give you a problem where it's a no-brainer. They'll only give you one value, and that's the value of the base, and they'll only give you one value, and that's the value of the height. Well, boy, you know, a 2-year-old can do that one. What happens if you got all 3 sides? So, how would we do this problem? We would start off class with the formula. So again, it would look like this. Area of a triangle. Little thing. That first time, at least include the symbol. You can do TRI if you want for triangle. And it's 1/2 base times height. Okay, we got our formula. Once you write area of a triangle once, I don't think you need to keep writing the triangle. You can if you want, but I'll just use A. All right, I'm going to do it up here while you do it at your seat. If you don't need any help, just go ahead and do it. If you need help, look up. Don't forget your units. So if you need help, look up. You got to determine what's your base, and you got to determine that according to your height. And then you have to figure out how to punch it out. Now we will go to decimal answers on these. So you're going to use your calculator. This one doesn't come out evenly. So you're going to have to use your calculator and punch it out. So everybody get your calculator out. I want to make sure that you can punch this out correctly, because it's a shame to do all the math and then not know how to do it with your calculator. So 1/2 times 13 times 3. Most students do 13 times 3 and then divide by 2. If you want to do a 1/2 times 13, calculators today, you can do that. I just do 13 times 3 divided by 2. Class, the answer is 19.5 what's? Inches squared. Can't. By the way, that reminds me, having taught for so many years, once you write that, I want you to look up at the screen. Is this ridiculous or what? Don't write this. I've seen students do that. Is that a ridiculous thing or what? It's like an oxymoron. All right? Or maybe the person doing it is just the moron. I don't know. All right. No, you don't want to do that. All right? Do not use a squared symbol with an inches symbol. All right? No, 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 no. Don't do that. You got to use IN for inches and square the inches. All right? We just don't do that. Don't do that. Don't do that. Pretty cute. In our day and age of shortcuts, it's not a bad idea, but we just don't do it, all right? It's just not accepted. Christina.
Used to do 13 times 13 divided by 2.
No, there's no 13 times 13. The base is 13, and yeah, the height is a 3, right? So 13 times 3 divided by 2. It's the easiest way to approach the problem. Make sure we can punch it in correctly. All right, so we got another problem here. So I'm trying to show you some of the different possibilities that you'll find. All right, so on this one, how are we going to start with the formula? So area of the triangle equals 1/2 base times height. Man, I'm giving you such great hints. All right, so again, you're going to need to look at the problem, and you're going to have to figure out the area of this triangle based upon that formula. Go ahead and do it if you can. If you need to look up at the overhead to figure something out, or at the board, go ahead and do that. But if you can do it without looking, try to do it without looking. You got to decide what's the base and what's the height. And hopefully you determine that the answer to this thing is 24 millimeters squared. Anybody do 1/2 6 millimeters times 8 millimeters? Anybody do it that way? 6 times 8? You had 6 times 8? Only one of you? A couple of you. How many had 8 times 6? Well, wait a minute. Are some of us right and some of us wrong? No. For a right triangle, one of the perpendicular sides is the base and the other is the height. It does not matter which. Do you see the right triangle? So again, watch. If I said the 8 was the base, then that's going to make the 6 height. Isn't it perpendicular and goes to the opposite vertex? It does. Well, if you want to say the 6 is the base, that's no problem, because then doesn't this side go perpendicular to the opposite side, and that's the height. They're interchangeable for a right triangle. Base and height are interchangeable for a right triangle. The two sides that form the right angle, one of them will always be the base, the other will always be the height. So how many got that correct? Okay. So you just remember that for a right triangle. Pretty simplistic. One of them's the base, one of them's the height. By the way, let me go back a second. What if, don't do this in your notes, they didn't tell us this, and they gave us a right triangle, and we didn't know the value of that side? What are we going to do? What would you do, Edward?
Or like the Pre-Algebra theorem.
All right, he's got the right idea. He said to use the Pythagorean theorem, right? And find the value of that side, because you need it to find the area, don't you? All right, putting things together that we learned, right? We learned the Pythagorean theorem. We'll use the Pythagorean theorem to come up with that side. We have enough to figure it out, so we could. All right, that might pop up on you, so I'd be aware of that. All right, let's do another one. Find the area. All right, you do it if you can. Oh, let me give you a hint. Always want to make sure I give you a very good hint. There you go. You needed that. Area of a triangle equals 1/2 base times the height. You try to do it at your seat. I'll do it up here. Correct side to use for the height. One half of 10 is 5. 5 times 6 is 30. 30 meters squared. This one's a little odd, isn't it? You know, the height is outside the actual triangle. So we had to show it perpendicular by extending that side. That's okay. That's the value of the height. That's okay. We did figure out the length of the height. So we're perpendicular to that base, and we go to the opposite vertex, right? So right there. So we're perpendicular to the base, opposite vertex. How many got that one correct? All right, good. You guys are getting the idea. All right, this next one you guys don't have a triangle for, do you? So we got to write in a triangle. I don't know what happened to my triangle. It like disappeared. All right, so all you have is a few numbers there. Don't ask me where they went. And I was trying to figure out, where does this triangle even go to make this work? So this is what I came up with. I drew a line like this. I had to come up here. I came across like this. And then basically I came down like that. All right, so that's what I did. And then I put a dotted line right here. And I stuck 4 inches right there. All right, so it doesn't have to look perfect. Don't worry about it. Something. Mine's not very pretty either. So, all right. So go ahead and find the area. Area of a triangle. Use the little triangle symbol for your brain's sake. Don't forget the half. Decide which side is the base, based upon what side is the height. Don't forget your units. Half of 10 is 5. 5 times 4 is 20. And hopefully you agree we got 20 square inches, right? I know I'm going a little fast on that, but you know, it's same concept. What's the key? Knowing the base and the height and making sure you got the right formula. If you can do that, you should be in good shape. Don't forget, area is always in square units. Area always in square units. Any questions on that? Okay, so let's go to trapezoids. Trapezoids. So last chapter we learned what a trapezoid was. We said it was a quadrilateral. How many sided figure?
4.
4, right? Quadrilaterals have 4 sides. So it's a quadrilateral with one pair of parallel opposite sides. In this case, the parallel sides are in green. I thought I made them red. But are yours in green too? All right. Thought I'd change that, but that's okay. All right, this formula is a little bit interesting. We do start with a half again. You do need a half. And then we need a parentheses, and this parentheses is important. Take your red. We need a base. But trapezoids have 2 bases. So we're going to go base with a subscript of 1. So base 1, that's what that means, base 1. Take your black, do a plus sign, and then take your red and do base 2, B sub 2. B with a 2 subscript, and close the parentheses. See, a trapezoid, we need to account for the length of both bases, and by cutting it in half, it makes it like a single parallelogram, believe it or not. That's what all that's doing. The half quantity base 1 plus base 2 makes it be equal to just the base of a regular parallelogram. In other words, don't do this, but I could split this off right here, take this triangle, switch it around, and stick it right there, and see how you'd have a parallelogram. So the 1/2 base 1 plus base 2 takes all of that into account and figures it out. Anyhow, it doesn't matter. We know the formula. Now we're missing one more thing. 1/2 the quantity base 1 plus base 2 times the, got to have a height. So times h, got to have a height. So take your red. I'm going to call the bottom one base 1, b sub 1. I'm going to call the top parallel side base 2, b sub 2. And then I'm going to take my green and I'm going to show you where the height is. It's perpendicular between the parallel sides. Perpendicular between the parallel sides. All right, well, I guess watch the trapezoid. Because I can do this because I have a smart board. Let me see if I can select this. Okay. I have the height right now selected. Has the amount of the height changed even though I slid it over to the right? No. Has the value of the height changed even though I put it over there to the opposite vertex? No. Has the value... Hey, what are you doing? I don't know what in the world, it like ungrouped everything all on its own. Oh, smart board. Why are you being such a smart aleck? Because it can, right? All right. I can outsmart you, smart board. I will. There, I'll make another line. It's not quite perfect. See if I can select it. Hey, by the way, could that height also be outside of the trapezoid? Would it still be the same length? Only this time, watch, it would be to the base extended out, right? Just like we did that one triangle that had the height outside. See how that's possible? Daydreamers and players, all right? Stop playing with your pens and focus, all right? These are the key things that are going to allow you to get these things right. All right, so, I could have undone that, couldn't I have? Oh, well. So, the key is you got to keep straight the base and the height. Oh, smartboard is going nutso on me. All right, let's get back here. Ugh. Ugh. Ah! Come back wherever you are. It's stuck in a weird loop, isn't it?
The board is saying no more class.
No, we don't care what the board says. The board is not in control. Oh, brother. Let's see if I go backwards. All right, board. Gonna drive me crazy. Gonna have to shut you down. All right. Shh. Think we're there. Come on. Stop. Folks, stop talking. Oh, he's going to go crazy one more time. All right. I got to be careful here. Look, the first blank there that you guys have in your notes, the height, the perpendicular distance between the, fill in the word parallel in green, between the parallel sides. Now, this is still a trapezoid. Does it have four sides? Yes. Does it have one pair of parallel sides? Yes. Yes. And therefore, then, where would base 1 and base 2 be? Remember, the parallel sides are the bases. So you got something in your mind? Now, does it matter which one I say is base 1 and which one is base 2? That's interchangeable. But the parallel sides have to be base 1, base 2. So would you agree here and here, right, on that trapezoid? Those are the parallel sides. So again, you could have said 1 and 2, but those are the two bases. You got to get that right if you're going to get the problem right. Where would the height be? This one side would actually be the height because it's a right trapezoid. It's a trapezoid with a right angle. But isn't that the perpendicular distance between the two parallel bases, right? And that's the definition of the height. So be careful with a problem like that. All right, so let's find the area of our trapezoid. How do we always start with the formula? No other thing to do but trap. You could write out trapezoid if you want, but again, we're trying to put something there that our brain will hang on. Let's do this first one together so we're making sure that we're doing our math correctly. All right, a half is a half. That's no big deal. Base 1, I'm going to label it the 10 inches. Base 2, the 6 inches. So I'm going to go 10 inches plus 6 inches in my parentheses. Make sense? Everybody with me? Base 1 and base 2. And then our height is, of course, the 3 inches, right? The only thing there. All right, so we got our formula up above. We now subbed in all our values. And now you got to be careful and follow the order of operations. We have to do what's inside the parentheses first. Agreed, right? That's like day 1. So 10 and 6 is 16 inches. Now you're ready to finish off the problem. Make sure you can punch it in correctly. This one you really don't even need your calculator if you think about it. What's a half of 16? What's 8 times 3? But again, you can use your calculator. If it were a test and you had time to go back and check it, I would check it because I've seen you guys multiply 8 times 3 and not get 24. So, all right, you hate to miss it for that. All right, times tables. If I were an elementary teacher, the one thing I would ensure every student knew was their times tables. It messes them up for the rest of their math career. All right, come on, smartboard, cut it out. You're getting me aggravated. It's like going crazy. It is nutso. Okay, we'll just deal with it. Let's do the next problem. So on this one, let's start with the full formula, area of a trap. Remember, every time you write it, it's going to help your brain to wire it so that you remember it. 1/2 base 1 plus base 2 times the height. Hey, what is that? Like about 4 or 5 seconds worth of work, right? But it can make all the difference in the world in your brain remembering the brain remembering the formula. Wow, it is really being weird. All right, whatever. Okay, so all I want you to do is put in the correct numbers. Put in the correct numbers in the right place. So you got to determine which sides are your bases. You got to determine what to use for your height. Which side are your bases? What are you going to use for your height? So I hope you decided the 6 and the 11 were your bases, and your 5 is your height, right? This one you're probably going to use your calculator because you're going to be a 0.5. So 6 and 11 is 17. So you end up with 1/2 times 17 feet times 5 feet. Who's got an answer for me? Ashley, what do you got? 42.5 inches squared is correct, or feet squared. 42.5 feet squared. 1 mark is feet, 2 marks is inches, right? A 1 slash is feet, 2 slashes is inches. So that's 42.5 square feet. You can say square feet or feet squared. In whatever case you're thinking, it's a lot of stink. All right. Let's see if I can get to the next one. All right, I'm not going to play with smartboard because it's being stupid. So your next blank, number 3, says to find the red base or green height, use the appropriate formula. Now, this would be a fun problem if I meant this, but where it says 30 inches squared, cross off the inches squared, make it meters squared. This is supposed to be 30 meters squared. We could do it with inches. That'd be a fun problem, but we can't have all that fun today. We just don't have the time. What a bummer. All right, I meant it to read 30 meters squared. All right, so how do you do a problem like this? We're looking for the height. We need to find its value. We're going to start actually with the area formula. That's why they told us the area of the triangle. So area of a triangle equals, be careful now, we're back to triangles, 1/2 base times height. Everybody agree? And now we're just going to sub in our values and solve the little equation. So do we have the value for the area? Yeah, it told us 30 meters squared. So where the area of a triangle is, you put in the 30 meters squared. The 1/2 is a 1/2, it stays. What value, I'm going to do it in red, what value goes in for the base? Somebody raise your hand and tell me the value for the base. Nia? You got to use the 25 meters because that's the side that has the height associated with it. Agreed? And what do we put in for the height? H. It's the variable, right? It's what we're solving. So it's just an equation. Let me show you one more step and then I'll ask you how to finish it. Now, because the half does not divide into the 25, and if it did, you would, right? If that would have been 30 instead of 25, 30 divided by 2 is 15, and you'd finish off that way. But because it doesn't divide, just leave it 25 halves. Just leave it as a fraction, not a big deal. So somebody raise your hand and tell me how to isolate the h, how to finish off this equation. How do we finish this equation? We've done them. Did it before. Allison? So tell me what to multiply both sides by. Not 1 over 30. Right idea. Chloe? 2 over 25, right? What is multiplied times our variable, right? Our h is on the right. So we have to multiply by a 2 over 25 meters. I keep my units. So I multiplied the left by 2 over 25 meters and the right. Do you agree that leaves the h all by itself? It does, and that's what we were after. All right, be careful here. Just do it on your calculator. 2 times 30 divided by 25. 2 times 30 divided by 25. Somebody raise your hand when you got it for me. Aaron, what do you got? Punch something wrong. 2 times 30 divided by 25. Christina? 2.4 meters. 2.4 meters. And by the way, so you know how the meters ended up, what is a meter squared? It's a meters times a meters, isn't it? And what's a meter divided by a meter? They divide each other out. What are you left with? Meters. Units work that way just like the numbers. All right, so be careful. Look, how do we know it was the 25? Because that was the side that was perpendicular to the base. Don't do this in your notes, but what if I gave you this value as the height? Then you would have used this, right? What if I would have given you that value as the height? Then you would have used that, right? So again, the side you use as the base is determined by what you use for your height. All right, the last problem. Another shaded problem. All right, not the only way to do this is to use this formula. Area of the shaded equals. Now, I don't know if you can see this, but what if I did the area of a trapezoid minus the area of a triangle? Does that give me the shaded area? So you may not see that. So if everybody will look at the board, let me in purple outline the trapezoid. Isn't this a trapezoid? And when I figure out all of its area, I have everything. But if I then subtract out the area of the triangle, what do I have left? The area that's shaded, right? See, I erased out the area of the triangle, just like you'd subtract out the area of the triangle. That's going to leave the area shaded. You follow? All right, so now we got to do our formulas, right? So you have to figure that out, and that's the hard part. You got to look at the shape and say, how do I come up with the shaded? And look, every problem's a little different. They're a little different. This happens to be a big trapezoid minus a triangle. But here's what I want to get to. All right, area of a trapezoid, 1/2 parentheses, base 1 plus base 2 times height. Go ahead and write that. It's a formula for area of a trapezoid. Keep your minus sign in red so we can keep the two of them straight. So I want you to watch what's going to happen. All right, area of a triangle, 1/2 base times height. Now, wait a minute, this is tricky. Come on, smartboard, cut it out. It's not going to cooperate. Can I even get back to where I was? Oh, I should have never touched it. All right, there we go. Good enough. I'm on the bottom, but just stay there. Okay, so listen and watch. Area of a triangle is 1/2 base times height. Now look, we got a couple different bases and a couple different heights. Keep track of them. Depends on the shape you're talking about. So let's go through. What is base 1 of the whole big trapezoid? Say it if you know it. Either the 8 or the 24. So this has to be the 24 and the 8. Aren't those the bases of the big trapezoid? All right, what's the height of the big trapezoid? Say it if you know it. 6, right? 3 and 3 is 6. Then we got the red minus sign. Half is a half. What's the base of the triangle? 24. What's the height of the triangle? And you'd have to finish that problem out. And for time's sake, we're not going to have time to finish it. That's the idea. Let the formulas direct you. Let the formulas lead you. Let the formulas guide you. Right? That is the key, and that is what you need to do. All right, you got your homework.